Here we go, boys and girls. This is the beginning of a new unit. This is Unit 1. So this is Assignment 1 of Unit 1, and we are beginning by looking at these things right here, these alligator-looking things. These are called inequalities. So let's take a general breakdown of what the heck an inequality is and how to understand one. So an inequality in BASIC will look either like that or like that, and there's going to be numbers or symbols on each side of these things. Let's take this first one, for example. Okay, this symbol right here, and again, you can have some sort of, let's put a number on one side and a letter on the other. Okay, now, looking at this, a lot of, teachers and things like that, try to explain by oh, it's like a shark or it's like an alligator, and one the little small eats the big and the big eats small, and something is hungry and the other one is. I don't think of it as being something is eating something. It doesn't really make any sense that way. But literally just look at this picture. Look at that symbol right there. Okay? And when I get a symbol, and I'm going to bring up another graphic here. And what I want you to think about is literally a measurement of something. Like a ruler. Let's bring in a ruler. Okay. If I am measuring this stuff, notice that the measurement on this left-hand side is 3. What I'm doing is I'm measuring kind of the distance between these sticks. And so the measurement on this left-hand side compared to the measurement on this right-hand side, where it's they're in essence the same thing. It's really, 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 really close together. So the measurements, I noticed that this left-hand side, the measurement is really, really big, and this right-hand side, it's really, really, really small. And so that describes what the x is and what the 5 is. So this is saying that the x, whatever it happens to be, the x is bigger than the 5. Okay, x is bigger than 5. So if I have a number line, 1, 2, 3, 4, 5, 6, 7, 8, etc., 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 what are potential values of that x? Well, x is bigger than 5. So that could be 6 and 7 and 8 and stuff like that. Everything that way. Okay? Now, does it have to be written exactly like that? No, it doesn't have to be written exactly like that. So for instance, what if I have x and 5 like that? Okay. What side is the big side? What side is the small side? So again, take measurements, and this side would be the big side. This side would be the small side. So again, x is bigger than 5. X is bigger than 5. So again, that would be numbers bigger than 5. Okay, technically called is greater than. X is greater than 5. Okay, what if I have something like this? So I have this side, which is really big. Again, that the measurement is really, really big. The side is really, really small. So I see that x is smaller than 4. X is smaller than 4. So numbers that are smaller than 4 would be 3, 2, 1, everything smaller than 4. Everything smaller than 4 would describe this x. So again, try not to think about it like the little shark eats the big shark, and then the alligators get involved, and like, well, because again, that kind of gets a little convoluted. That gets really kind of hard to understand sometimes. Okay. The next thing that I need to talk to you about these symbols is sometimes these symbols will have a line written underneath. So here we have two symbols, and one of them has like a line written underneath. Okay. How you would say this symbol is, this is technically is less than. Okay, so the alligator looking thing is called an is less than. Okay. What this bar does, this puts a caveat onto it that says or equal to. So how you would technically say this lower symbol is, it would be is less than or equal to. So if I give you some numbers, okay, let's put x on the small side. Okay, x is on the small side of both of these. And let's say it's smaller than 5. Okay, big deal. Okay, x is smaller than 5. Okay, how are these symbols different and how are they similar? Okay, this is what I'm going to be trying to explain here. And you probably already, many of you already know this answer, and that's great to have kind of a head start on this. Okay, so if I have this number line here, and I have, 1, 2, 3, 4, 5, 6, 7, 8, etc., etc., etc. Okay, so if I have something that is less than 5, that would be numbers that are less than 5. So for instance, 1, 2, 3, 4. Those are numbers that are all smaller than 5. Okay, because again, 5 is on the, you can see it's on the big side. 5 is on the big side. So 5 is bigger than x. X is smaller than 5. Okay, now, because it's less than, we're talking about these numbers 1, 2, 3, 4, etc., etc., etc. If it is the or equal to brand, all right, that means or equal to. That means the number can be 5 itself. Because if I said, oh, something is, I have less than $10 in my pocket. Okay, I have less than $10 in my pocket. So here's my pair of pants, there's my pockets, and I have less than $10 in my pockets. Does that mean I have $10 in, I could potentially have $10 in one of the pockets? Well, maybe. I got to be a little bit more descriptive. All right? So less than 5 means everything's smaller than 5, but does it include the 5 itself? If it has that or equal to bar, yes, it includes that 5. So it'd be that 5 in everything less than that 5. So every number less than and including 5. However, if it's this just is less than without the or equal to line, then what it can be is it's going to be all of these numbers less than 5, but it will not be the number 5 itself. I mean, it'll get crazy close, like 4.9999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999999 but it stops. It won't be 5 itself. It'll get crazy, crazy close to it, but it won't be it itself. And so that's what like an or equal to means. And how do you describe these differences as far as pictures are concerned? Okay, as far as pictures are concerned, whether it be a graph or something like that, if it's this or equal to, okay, it'll be a filled in dot. It'll be a filled in dot. And so this is how you would graph it. This would be is less than or equal to that 5. If it's just straight up is less than, what it will be is it'll be a dot, but you're not, it's not filled in. It's like more of a circle. And so you don't fill it in. So if it's a filled in dot, that means it's an or equal to. That means the 5 is actually there. If it's not filled in, that means you can get wicked close to 5, but it's not actually going to be 5. Okay, let's get to some of these problems and let's take a look here. So I see that x is bigger than or equal to 5. So x is on the big side. So let's go to 5. Right there, 5. And because it's or equal to, I fill in that dot. And it is bigger than 5, so that means I draw a line, a darkened in line of everything bigger than that 5. Okay, here, in this next problem, this is kind of like two problems at once. Okay, what I want you to do first and foremost is focus on this left-hand side. So negative 5x. Okay. And then the other part of the problem is when I focus on this right-hand part, which says x1. Okay, and we're going to graph both of these simultaneously. Okay, focusing on this left-hand side, I see that the x is bigger than negative 5. So negative 5 and x is bigger than. So I'm just going to kind of start this off. And so it's going to be all of these numbers bigger than. Okay, it is also or equal to. So I darken that in. So that kind of starts the process. So x is bigger than negative 5. Okay, focusing on this right-hand part of the problem, you notice how the x is on the small side. So it's smaller than positive 1. So I go to 1. Okay, it is or equal to. And it's smaller than that. So that means all the numbers this way. And so what we do is we just start here and stop here. So yes, it is bigger than negative 5, but it's also smaller than 1. So again, this left-hand side and this right-hand side. I see that this x is big over here and it's small over here. So it's bigger than 2 and smaller than 8. So I go to 2, or equal to, and it's bigger than 2. I go to 8. Notice how I do not darken that in because it does not have that or equal to. Okay, so I don't darken it in, and it is less than. So that means smaller than, and so where these things will link up is right there. So this is bigger than 2 and smaller than 8. Okay, all real numbers, that means x can be any number that you want it to be. So that means it's all of these numbers and then some. So what you do is you just darken it in. And if your graph goes off this graph, like goes on and on and on, you make one of these arrowheads. You make an arrow. So this is saying, hey, this is going to go technically to negative infinity, and this is going to go technically to positive infinity. It goes on and on and on forever. So you darken this entire line, and because it goes off the graph, you put these big old arrowheads on there. All real numbers. It's every number. Okay, here they have a representation. So how can I represent this using inequalities or alligators? They want me to use alligators. All right, so let's describe this. Let's describe that portion of the project. All right, so x is smaller than 3. That's what that portion of the problem is. And now let's focus on this portion of the problem. That means x is bigger than 3. Notice how these are not or equal to. All right, so if I write this all together, x, I see that x is bigger than 3, and while also smaller than 3. X is bigger than 3 and also smaller than 3. Okay, when you do write these things in line, the alligators almost always point to the left. So if you can help it, point them to the left. So I began us off with, I need alligators to look like that. Right? I need alligators to look like that, so I could write it like this, but then I also kind of have to flip-flop this one right here. And I have to flip-flop that one. But again, so that means x's are bigger than 3 and also less than 3, but notice how neither of them are equal to 3. One's a little. Okay. Domain and range. Domain and range. Domain is a, I'll talk about this interval notation here in just a second, but it is the leftist most point to the rightest most point of a picture. If I can spell words. It's the leftist to the rightist. It's the x's, if you will. It's the x's. The domain are all of the x's. And the range is the bottom, is the lowest. To the highest. Okay? These are, in essence, the y's of a picture. All right, so looking at this picture, what's the leftist most thing that we have? And here is the leftist most thing that we have. And so what is the location as far as the x's? What is the leftness of that point? -4 is the leftness of that point. So -4. Okay, and what is the rightist? What is the rightist? So I go along this path, going right, going right, going right, going right, and there is the rightist. And the x, the left and right portion of that is 6. 6 is the x coordinate, and that is the rightist that it is. So the domain is -4 to 6. -4 to 6. All right, the range, the lowest. What's the, if I start at the very, very bottom, what's the lowest part that I'm going to hit? Boom, right there. That's the lowest that I'm going to hit, right there. So that occurs at -5. -5 is the lowest thing that this thing gets. This is the bottom. Now, where is the top? Some people might think, oh, this is the top. But that would be incorrect. That is not the top. That is not the top. Is there anything above that dot? Yes, there is stuff above that dot. Here is the top. That's the top of the mountain right there. That's the top. So the range, the bottom is -5, and the top is at a y coordinate of 1, 2, 3, 4. Has a y coordinate of 4. It is up 4. So the lowest is -5, and the highest is 4. Okay. Now, so that is what the domain and range is. Now, all that's left is to put some sort of brackets around these things. And there's two different types of brackets. There's a round bracket, and then there's a square bracket. Okay? If you use the round bracket, that is kind of like saying x is less than 5, or something like that. Okay? It means it is not equal to that number. So if you get wicked close to something, but not actually there, you use a round bracket. If you use a square bracket, that would be something like or equal to. That means it actually does touch 5 or whatever. Okay, so looking at our domain and range of number 6, look at the domain. And let's take a look at that -4, the leftist-most point. Do I actually get to -4? Is there an actual dot at -4? And yes, there is, because look, it's filled in. So that means that, yes, it actually does hit -4. So it gets a square bracket. Okay, go to the right. The right is 6. That dot right there. Does it actually get to that dot? No, because it's an open one. So that would be a round bracket right there. So it goes from -4 to 6. It will include -4, but it does not technically include +6. Okay, same with the range. Same with the range. The lowest was that dot right there, which is at -5. Is there an actual dot there? No, there isn't, because it's an open. So that is a round bracket at the lowest. And then the highest was right there, which is midstream, and there is a dot. And yes, there is something actually there. So that gets a square bracket. So left to right, bottom to top. Okay. Let's talk arrowheads here just for a second. So arrowheads. I'm talking about this guy right down here. Okay. What you do when something goes off the graph, or if something has an arrowhead, what you need to think of is this. It will go on and on and on in all directions. Okay. So when I see this, what I think of and what I oftentimes draw in my pictures is this. Okay, what is that doing as far as up and down? And what is it doing as far as side to side? So I see that it's going down, so I draw an arrow down, and it's also technically going to the left, so I draw an arrow to the left. So like number 8. This is going to the right, and this is technically going up. Okay, that's what I kind of do with arrowheads. And what this means is this. If it's going to the right, that means it's going towards positive infinity. It's going towards positive infinity. And what an infinity symbol looks like is like the number 8, but written sideways. And I know it's kind of hard, it's difficult for the first time you write them. They're kind of difficult, but it's a sideways 8. If it's going to the left, that means it's going towards negative infinity. You know, just kind of like an axis, how these are like 1, 2, 3. This is -1, -2, -3 kind of idea. So you go towards a positive infinity, or you go towards a negative infinity. Again, if you go up, you're going towards a positive infinity, and if you're going down, you're going towards a negative infinity. That's how to understand arrows. And this is the world of infinities. So, taking a look at number 7, let's go ahead and figure out this domain. Okay, so what's the leftist? Okay, and so the leftist of this is the arrow, which is negative infinity. Negative infinity, infinity is smaller or bigger than anything. So this picture technically begins at negative infinity. That's the left. The rightist is this point right there that has a coordinate of 6. Okay, you are never ever actually going to get to an infinity, so that an infinity always gets a round bracket. You will never put a square bracket on an infinity. You are never actually going to get there. The 6, I noticed that the 6 is an open dot, so I will not get to that 6 either. Okay, the range, the bottom. I have an arrow, and that trumps all. That takes charge of everything. So the lowest S thing will go is negative infinity, and the highest is technically that dot right there. It's not at the 6, 2. It's technically right there, and that has a height of 3. Will it get to the infinity? No, it won't get to the infinity. Will it touch 3? Yes, it does actually touch 3. So it gets a square bracket. If there is a point somewhere along, like say, hey, that's the, and it's like kind of like midstream in your picture, that means it will actually get to whatever that dot is. Okay, if it's somewhere along the way, then yes, it will actually touch that. All right, so this point is at negative 1, 2, 3, 4, down 2. Okay, so that dot right there is at negative 4, negative 2. So the domain, the leftist is negative 4, the rightist is infinity. It obviously doesn't touch infinity, and we have a closed dot at that negative 4. Range, the lowest is, again, that dot, so that's at negative 2, that's the lowest, and the highest is technically infinity. I know it's only going up just a little bit at a time, but again, if this goes and goes and goes forever and ever, it's never technically going to stop going up. It's never technically going to stop going up. It'll go up slowly, but it's never going to stop going up. Thus, it will go up forever. All right, so what I see is this is the leftist most point, this is the rightist most point. So this domain will go from negative 1, 2, 3, 4, 5 to positive 1, 2, 3, 4, 5. Close dots on both of those. The range. The lowest is, this is the bottom, and this is the top. Okay, there is no arrowheads, so that's what they are. So the range is from negative 1 to positive 1, 2, 3, 4, 5, 6. Close dots on both of those. Okay, this arrowhead goes up and to the right. This goes down and to the left. Okay, so the leftist is, again, that negative infinity right there. So the domain, the left is negative infinity. The right is this positive infinity. It never stops going left, and it never stops going right. The range, the bottom. arrow going down, and then I also have an arrow going up, so that has a negative infinity to an infinity as well. Again, infinities always get round brackets.